Well, hi, good morning. Thank you so much for joining me in my shop here on June 21st. I think the smoke has returned because the sun is fairly high in the sky already. It's 8 o'clock in the morning here. And instead of being yellow, it's still reddish like a sunset. And the sky has a weird look. And disappointing to me. I stayed up late as I could last night. I have trouble staying up late because I'm up too early in the morning to get out with my telescope and view the stars, but you can't do it. There's too much smoke in the atmosphere, even though I don't smell any smoke, not like it was a couple of weeks ago, but there's still enough smoke in the atmosphere to just kind of gray everything out. So, my gosh, fires everywhere. There's actually a couple of fires burning south of me, about 150 kilometers away, but I don't think there isn't really a forest south of me. South of me is patchy bits of woods here and there, but it's 90% farmland south of me, all the way down to the American border, near Detroit, Windsor, that area. Going north from here, it's forest all the way. Yeah. There's 1,000 miles of forest north of me. If I just go in the right direction, I can go 1,000 miles. Probably more. Yeah, that's what's on fire. Okay, enough of that smoke talk. Today, I think big breakthroughs are coming. I think I've made enough observations now that I can figure out exactly what these coils are, who's doing what is supposed to do what, where these wires are supposed to be going, who's what hooked up, wait, haha. That's what I think. So, why do I think that? Well, yesterday I made a discovery that in fact there are 3 coils in this form. There's one here, one you can see, and one underneath here you can't see. 3 coils. I believe this is 2 coils. And I believe this is 2 coils. If we look here on this one, for instance, we see 2 leads on the top and 2 connections on the bottom connected to this capacitor. If we look at this one, you can see 2 leads on the top and it looks like, sorry, sticking my head in front of the camera there. Can't see absolutely clearly, but I believe it's just 2 leads on the bottom. Yeah, and it looks like there's no connection to these capacitors. I'm not sure about that yet. This one, well, looks like there's 4. I'm not going to count them now. 4 or 5. I have them here actually on this diagram. I'm not even going to count these. I think it's 4 or 5 on the top here, and 2 more on the bottom for 3 coils in here. So we're going to jump now to the schematic and look for the 3 coil transformer. The three coil transformer. And with all honesty, I looked at this already before I turned the cameras on, and this got me a little excited because, see, there's only 2 coils, 2 coils, 3 coils. Here it is. So this set of coils here is for the local oscillator. And these 2 are for the antennas. Aha! Would never ever conclude that looking at the geometric arrangement of those 3 coils, because 2 of them are on the same, tipped the same way, and 1 is tipped another. So you think, well, 2 of them are these antenna coils and the other, but that's not the way it is. If these 2 antenna coils are at right angles to each other, and I guess they didn't care about the interaction of this one, or didn't care as much. Okay, so now I can be kind of reassured that this is the oscillator coil. Now the problem is, based on earlier wiring check, which I'm going to check over again, maybe I'm full of crap here, the antenna wire is fed over here. Goodness knows, the same confusing situation I've been through with these coils, perhaps the original repairer also ran into similar confusions about who's what. Look at these trimmers here, because these trimmers are going to help us figure things out too. So the trimmers on here, oh my gosh, you know what, this is in conflict with the radio. Okay, I'm going to start eating my words already. These 2 trimmers, they are, no they aren't, I was going to say they're connected right together. but they're not, because there's two trimmers in here that are parallel. Or are they? Did I make a bad observation very early on? I think I might have. That's pretty interesting. You flip it to broadcast, you bring in this extra trimmer. Or you select this trimmer. You bring it to short wave, you select this trimmer. Okay, that makes perfect sense. Often you're switching coils. You're just switching a trimmer? That can't be enough, can it? You're switching something down here too. Oh boy, oh boy, oh boy. Okay, not to get into the weeds, Jim. Don't get in the weeds. We're just trying to verify what is what. So it's quite clear though. 3 coils makes an oscillator in this radio. And 2 coils here, or a simple transformer here. Let's just look at the output from here. So the output from here goes into grid number 0. Grid number 0, I think I would call it grid number 1 myself. Oh, GO, grid oscillator is what that is. So there it is, the first grid. This tube's pictured upside down from what we commonly see. So the heater's up here and the plate's down there. So that's very common that the oscillator is fed to the first grid. Then, you know, the electron flow through the tube is then modulated by whatever's on that grid. And the actual signal is usually fed to grid number 3. But it looks like, well, here it is here. Where's that connecting? 1, 2, 3, 4. Well, this is the grid cap on the tube, but you can't see the wire for which one of these grids it connects to. Wouldn't it have to be this one? Screen. Yeah, you know, this has not as many elements in it as a typical mixer tube. So using the first 2 grids for signals, does that make sense? G antenna. What have they done here? G. GA. I can't figure out the tube now. Hey, come on, this can't be happening. G. Okay, grid oscillator. Grid antenna, I would want to say, but look where it's going. What's it doing down here? Oh my gosh, I thought this was started out today going, oh, this will be easy. I'll just sort it out just as, you know, as quick as you can say coffee. Well, okay. Nothing is going to be as simple as I expected here. GA. And of course, this isn't the tube that's in the socket anymore. It's a different tube, and I think it has more grids in it. Or am I just confused? So usually you have a grid, screen, suppressor. Yeah, I better stop and drink more coffee, I think. Okay, let's go back to the coil situation. So these are the 2 antenna coils, and they're just straightforward transformers. And they do not have a 3rd coil in them. So that has to be the 2 I'm looking at right now, and the antenna should be coming through the switch to one or the other of these 2, not to here. Okay, let's look back at the radio and just see, because I think maybe I'm just remembering things wrong. We have a memory eraser in our house. It's very effective. It's called a flight of stairs. At the top of the stairs, you can plan to get something from the basement or down here, but by the time you get to the bottom of the stairs, you can't remember, because the stairs are erasing your memory. Do you have that problem? Get to where you're going, don't know why you're there? Or worse yet, get to where you're going, see something that needs doing, do the something, think you've done what you came to do, go back, get back to where you came from and go, oh, wait a minute, I was supposed to do this. I spend a lot of my day like that. Yes, I know. Old age setting in. Okay, So we'll follow the antenna. Let's get focused here. I'm in a funny mood this morning. So we have the antenna connection here on the switch. And then it's connecting. I'm going to look at this again. I don't trust myself here. Antenna. So I figured out that in this position is short wave. This, wow, even that could be wrong. Remember this? I found it was a local oscillator happening there at the broadcast, in the broadcast range, and in this setting. But this setting seemed to bring more radio out. So this setting is phono. And the shortwave setting was just nothing. Yeah, when we looked at the SDR, we saw the local oscillator was hardly shifting between here and here, which is not right at all. I assumed the middle setting was broadcast. But maybe it wasn't originally, and maybe this switch has been rewired, and maybe the fellow doing this got so confused, he's mixed everything up here. Maybe. And I don't want to be that guy. I want to be the guy who sorts it out. And yeah, it's taken time, no doubt about it, but it's so easy. Like, here's the rule. This is a little piece of philosophy from me, okay? Investigations continue until the investigator is satisfied, not until the truth is known. Now, if you're lucky, at the moment he's satisfied, the truth has been revealed, and that's what's making him satisfied. But how do you really know the truth when you're doing an investigation, especially into something like this? So you look into it, you find this, you realize that. At some point you go, good, I've got it. And I'm very close to that until I looked at the schematic earlier. I was feeling really close to, I got it. It's not that I know the truth, it's that I'm feeling satisfied about the picture and story I've developed at this point. You know, trying to find the truth is tough. Isn't it tough these days? Seems to be. So what's the truth here? So oscillator coil and then 2 antenna coils. And we're tracing the wire, and I'm looking at the switch and forgetting what I'm doing because it's as if I'm going up and down those stairs here. Okay, so we're going to go back to this. Put this on what I believe is AM, middle setting. This connects the incoming antenna wire to this red wire here. And this red wire is coming to here. It's coming to a connection down here, which has been remade, resoldered. Now there's another sort of, that's sort of the entry into the coils coming here. There's also an exit from these coils, the antenna coils, going to the grid of the first 2, which I am going to carefully prove out here. That way. Wait a minute. Okay, so the grid of the first tube is coming off the top, off a terminal on the capacitor, the tuning capacitor. So probably the wire is actually coming from the bottom terminal. It's probably this one right here. Oh, I gotta prove that. I have to prove that. Let's go forward with evidence and proof all the time. I can see it. Yes, that's it. That is the antenna wire. Well, no. That's the grid wire. So the signal's coming in here, going around, and going back out on this wire here. Of course, it's not really going around. So this wire should have a connection to it. Well, why is it even on the switch? Oh my. Okay, so in this position, there is no connection leaving the switch going. Have I got the right wire? For sure I've got the right wire here. Yeah, there's no question. There's no connection to the first grid. This is the phono setting. And that wire looks like it's never been resoldered. It is where it's always been. A lot of these other ones look like they've been resoldered. So this position, that's just totally different from what I thought. And then this connects it in, and this connects it in. So this is AM or shortwave, and this is AM or shortwave. You gotta guess. AM in the middle, shortwave there. Phono back here. I had this totally wrong. Okay, so we'll put it back in the AM position. What I believe is the AM position. So in this position, the grid of the first tube is picking up its signal from this wire here. So this wire looks like it would be connected to the secondary of this transformer. This is the one I was plunging the sensor down and couldn't decide if it was working or not, but I believe I checked the resistance of these and found them both to be continuous, both like the set of wires down there and the set up here. So all coils were continuous. So what's the problem? The problem is the signal never makes it to the grid. The signal never makes it to the grid. Now, maybe I didn't do that right. Let's check for some continuity here. And the other ones, I see a red wire coming over this one here. Very awkward to see in there. And then the wire has a short extension, like a ½ centimeter extension on it, copper wire extension to reach a terminal. Where's the other terminal and the other wire? There's got to be a... So there's something going on down here, and this is the exact spot where a couple of you have said they think there's a broken connection they could see in the video. But I think it was just a visual effect. I don't think it was really true. So there's 4 capacitors here. 2 of them are tied together at the far end down here. Don't think this connection is connected to this at all. Hard to tell. Well, how can you have one wire coming over? You can't have one wire coming over. You need to have 2 wires coming over. Well, you'd have one coming over carrying the antenna. The other one could be grounded. That's what it shows on the schematic. So where's the grounding? Where's that taking place? Where is the grounding? Don't see anything inside there. How would they do that? Well, obviously, often, you know, yeah. Never mind. Just continue the babble while they do this. But, okay, so there's a little tidbit of wire off this capacitor. There should be a capacitor involved. And I bet you that little tidbit of wire is the lead. That would be going to this capacitor. And then the other side, it's joined here, and then there's a wire going way up to here. What's the deal with that? I don't know. It's going out then. Oh, it's too complicated. Where's the ground? Okay, let's look for it this way. Okay. This is the wire coming over. 17 ohms to ground. Okay, so there's a... Okay, so is it this? Is this grounded? No. Is this grounded? Come on, really? Neither grounded. This bar is grounded. What's going on? I didn't get a good reading there. Is the ground missing? No, I can read the coil to ground. 17 ohms. Something up here I'm just not seeing. I just poke around. I can't poke around. Here. It just must be there, and I'm just not seeing it. Well, I'll pull this close-up camera out of here and we'll take a look. We will take a look. And we'll see what is to be seen. Just looking down inside. See a rivet on, opposite sides. And I don't see any wire there. I don't see any wire there either. So the coil, so there's the connection down there. The red wire coming over, short extension to a terminal. If we look at the coil arrangement, and I noted this before, the two coils that look identical, and then the lower one looks different. These two look identical. This one looks different. It's got a different color to it. So my guess is this is one coil here wound this way, and this is the other coil. My guess would be the upper coil comes to these upper terminals, and the lower coil goes to the lower terminals. Okay, that's just great. Now what? You can actually see one of the lead wires on the center coil coming up, out, and then casting across and disappearing from view, but it's probably heading to this coil to continue. Probably wound from the bottom up. I guess you have to wind these from the bottom up, don't you? Bottom up, and then you get to the top, you then have the lead wire, and you just play it across. It becomes the bottom of this one up to the top, and then the top wire is somehow connected to one of these terminals. There it is. There's the top wire just running along the valley here. Right in. You know where I'm trying to get to here. I'm looking at a TV camera. It's confusing to do this up here. Hey, what happened to the coil right there where I'm almost poking it? A little bit of a disruption there. So hopefully that's just somebody flaked the wax off. It could even be me from poking around. So where is the other? I still haven't found it. I got one wire coming over, and the other terminal is, let me get the camera up in here. Let's see if I can do this. Well, okay, so there's the red wire coming over and the connection, which looks like a cold solder joint. Now, what am I seeing here? It looks a little weird to me. I'm looking at each wire and just trying to figure out where it's going. Well, there's one. This one I'm wiggling here. This guy. Where's he going? Where's he going? He's going right where we might be interested in it. Get up here like this. Sometimes I get too involved with these cameras. I should just be looking with my eyes. Okay, I'm going to do that. I'll just use my human vision here. Ignore the cameras and you for a moment. This is the green wire. And I see it. Okay, I see the connection. It's down there. Okay. Okay, seen it. So now we go between the green wire and the red wire, and we should get the 17 ohms. So the green wire is grounded. Okay, green wire. This is this wire here. Coming to here. Is that grounded? How can this be? How can you get a... what I think I'm doing is I'm reading right across a coil. A coil that if we come over here, we get 17 ohms. Is that crazy? Ant crawling on my bench. Black ant. They're ranger ants. Those black ants can travel like half a kilometer. Yeah, I guess you can see him over here. Where is he? There he is. Make a run for it. He has a right to life too, but I would step on him if I had the chance. Okay. So how do you get 17 to ground and 2 leads coming over? And 1 lead not showing any ground. Oh, was I touching the wrong terminal? Maybe I was touching... No. Open that way. You get this. How do you get this? You get this. I don't know how you get this. How do you get that? You have to have a incorrect ground. Is there some connection through here? There's some connection. If I go on the red wire. Coils can short to each other, but these coils are not in contact. They're not touching, so there's no way they can short. So how do you get this? That's on that end of the wire. Okay, the other end of the same wire. What? It's the wrong wire. It's this wire. We get the 17 there. Yeah. Throw the switch. Okay. 17. Throw it the other way. Always 17. Now, this wire, in this position, this red wire is connected to nothing back here at the switch. So somehow there's 17, somehow this coil has a ground. And there's 17 ohms worth of wire between here and the ground. So there is a terminal. The capacitor terminals are here. Same set behind the coils, all standing up like that. There's one kind of aimed at this coil back here. Is it possible it's jammed in? Well, only if it's grounded too. It can only provide a ground if it is a ground. Ooh. There's a grounded terminal sitting right there. Ooh, that should be the same as this other terminal. I don't know if I can get to it. Yeah. Because they're tied together back there and brought to ground. The terminal has poked into the wire. But if that were the case, then I would read, 17 ohms in one direction, but back from the other way, I should read the remainder, because the coil is actually 17 plus some ohms. But I don't read it back the other way. I get it just an open. Well, I don't know, 600 ohms. Let's go up. Maybe I'm being fooled by that. Doesn't look like it. And of course, we've got to do switching. Of course, we got to do switching. Wrong. I think I'm touching the wrong terminal here. No, it's the right one. Green wire. Green wire goes down to the bottom, right? Green wire goes to the bottom, right? Right. Green wire goes to the bottom. Green wire currently connected to green wire connected to this red wire. Green wire connected to the red wire? Yep, there's a ground there. Where's the ground coming from? I haven't found any grounded terminals yet. Or is there... Oh my gosh, this is confusing. Holy smokes. I thought this was going to be a snap. I got it all. I thought I had all the pieces but one little piece. It would fall into place. And I have a beautiful picture in front of me. But what I've got is still question marks floating all over the place still. Oh my gosh. Oh my gosh. Well, this is just the antenna. And we still have this whole oscillator coil schmazoo over here to ponder, but don't put that on the plate yet, Jim. You're gonna lose your appetite. Too much on the plate here. Yeah, coffee time, because I'm stuck at the moment. I don't know what to do next. We don't know what to do something, and that something could be drinking coffee. I'm working away here with these very, very low resistance readings, and my clip leads are interfering with things, so I've been going through and checking clip lead resistances. This guy seems pretty good. We're going to clip him here. Then, this is going to the coil here, the one which seems to have a ground on it. We get 0.5, 0.4, 0 right there. Where's the 0.5 or 0.4 coming from? We'll go on this connection here. Oh, I'm all confused again. There's the 17. Yeah, because I'm reading through the coil here, because it's the lower connection and I'm touching the upper connection on the coil. Well, all indications are this coil, well, all indications. It's A-OK. Coil's good. other wire. Zero on the red wire going over there. Now how do we get a ground into here? Put that back there. Go here. 0.5. Yeah, man alive. Okay, let's skip, because I measured it 17 ohms 1,000 times there. Let's advance the test to the secondary side here. What I believe is the secondary side. 5.8. 0. 5.8. So that sounds like it's continuous. So my earliest testing on this coil suggested everything was okay. Where's the ground coming from? Where is the ground coming from? So red wire goes over here, and in this position the red wire is open circuited. There's no contact in the switch. So red wire's open. I'll clip on it. Is this the right way to do it? What am I going to find out there? What happened to the resistance of this coil? What happened to the ground that was on it? It's still there because I'm reading through ground here. There's something I'm missing in this. There's something more I'm not seeing. It must be something more going on. So you see the two contacts, the two terminals rising up for the two trimmer capacitors are tied together, and then this is the one that seems to be contacting the coil. But is it soldered in some way? Oh my gosh. So, okay, so yes, so you see the terminal on the back of the coil, down at the bottom there. You see the wire. There's a wire in the background, right up against the back wall. Now I think that's, let me get my stick. Here. This is the wire I believe is going down to the back of that coil. Now when I'm moving it, I'm moving another wire. Let me push it this way. Well, it seems to be coming right past. Well, that's okay, so there's a red wire and the green wire. They seem to be kind of touching each other back there. I have to go attend to my telephone here. So that's the red wire I'm poking on. Where did the green wire ever go? Okay, we move the green wire again. Where are you going, green wire? Here it is here. See, it's going around this coil and coming to a terminal here. So conceivably it's soldered to that terminal, but it shouldn't move this much. Well, you know, where is it actually going? It's going, reveal yourself, will you? That's the red wire it's bumping into. Come on. You can't. Come on, man. Okay, I'm going to try to shove the camera right into this spot here if I can. I'm going to shove it right in here. We're going to break something doing this, okay? That's about as far as it's going to go. Wiggle the green. Let me slide my pointer down the green wire. There it is. That's the green wire, and it's going down. And you see how it's bumping the red wire in behind it here. So that's why I move it. It moves the red wire. It sure seems fixed at its far end. It's got to be going to the bottom of the coil. Where do you get the ground connection in here? How can this happen? I'm almost certainly, yeah, sure. Yeah. Nothing's almost certain here. Nothing is almost certain. So we know what goes on with the green wire. We know how to free this end up by turning the switch in a certain position. This end goes nowhere. The other wire, the red wire, which is this one, comes over to here. So is it possible to turn the switch so both ends are open? I think that's possible. Let's see if that is the case. I'll go back to using this guy here. Get both ends open, then the coil is free of the radio circuitry, and then we can do more tests on it. Okay, so starting with this green wire right here. Looking at the contacts, you can see the green wire is going to a terminal that's touching nothing. Now it's touching, now it's touching. So contact with nothing, contact with something. Ooh, is this a double-sided? So I've been fooled by these switches because they have stuff on both sides sometimes. Doesn't look like it. Yeah, these switches though, the switches and coils are really, no, there's nothing on here. Nothing on the back. Switches and coils like this, they do me in, just like you see happening now. Okay, so that's the green wire. So we know if we put it in this position, the green wire is open. So now look at the red wire. Okay, the red wire in question is this one here, this guy right here. Come on, this other wire's in the way. So there we are. The red wire comes over. It appears to be not connected. So this makes sense. The switching in the radio is switching both contacts on the coils. So one coil selected and different coil selected. And I don't know what's going on there. So based on my last conclusion, this would be phono. This would be broadcast. This would be shortwave. Well, wait a minute. The coil's disconnected. And the other one is disconnected. Both wires are disconnected in this position. So that coil is now freely floating in the universe, not connected to anything. Good, let's test it. Let's test it. Now it should not, we should see open circuit here. Go down here, touch this thing. 17 ohms. 17 ohms. So again, how is the ground getting into contact with that coil? There's just nothing grounded here on this, except the thing that's grounded. Okay, so one open wire over here shows the 17 ohms. I'm a winner. So this meter is designed to wake me up periodically, because in case I fall asleep while I'm working. And that's the other wire. Oh, wait a minute now. So this one shows open. But maybe it's just higher, on the 6,000 scale. So how do you get one wire showing a short to the chassis with no chassis connection in sight, and the other wire going to the other end of the coil just shows open? How do you get that? And what I was trying to do with the clip leads, I'll see if I can just do it with my hand here. The 17 has been very, very consistent. Oh, it's not 17. Wait a minute, wasn't it 17? What did I just do? Oh, I know I didn't put this up here. Okay. 17, very consistent. How do you get a consistent reading? If there's an accidental contact here, then this 17 will go wonky. It will go wonky. You know, if there's something just rubbing something, it would not be stable. What am I not getting here? And those capacitor terminals. Well, there's the ground. I think it would have to be the case that somehow. Oh, there we go. I was freaked out there. Okay. It has to be a fairly solid connection. It could be the connection that a few of you saw in an earlier video and thought was broken is actually a connection that should not be there and is there due to an error made by the last guy. But there has to be a trimmer on here. That the trimmer would normally be connected to the secondary side, would it not? Very interesting. So this connection is tied right to the capacitor. Assuming this is the secondary side because, well, the other side looks like the primary. We have the secondary side here with a trimmer on it. I'm drawing a complete blank, that's why I'm silent. Okay, stop. Coffee time. Very hard to not make assumptions here. So I assumed that these two connections are connected to the upper coils. The lower coil, where there seems to be trouble, all assumption really, would be connected to the lower terminals. I mean, that makes sense, but I have had a radio in here just a while ago where, no, that's not how they did it. One top terminal went to the bottom coil, and the other top terminal went to the upper coil, and vice versa, or likewise at the bottom. So I'm going to look in here again. I've adjusted the focus on my little camera there. We can get a closer look at the wire that's connecting to this terminal here. How far down there does it go? Does it go all the way down? No. No, it would be going down by what I can gather here. Is that looks like a solder point on the wire. Okay, I'm just going to assume that's wax and dirt and stuff and not solder. The wire looks similar all the way from where you can first see it right up to where it passes through the rivet to come out. So again, it looks like, and then the other top terminal here. The wire's on the outside. Yes, the wire's on the outside. So you have the outside top, inside bottom. Two top terminals doing the two top, or the one top split coil. Lower coil. Get a little more tighter focus on here. By the way, these don't look burned or overheated. Not to me, anyway. I have the focus set such that I can't get the camera close enough to what I want to see and get it in focus. I can just see this close up, like this stuff that's really close to the camera now. Holy smokes. You know, right in front of me the whole time, and one of you mentioned this, right in front of me the whole time is the opportunity to take this whole piece out together as a single unit, and even just take these screws out and just lift it. Just lift it up, leave all the wires, just lift it a bit. So my comment about that is, yeah, that's definitely something that might end up happening here, but only when I feel really sure about why I'm doing it. I don't want to go on a fishing expedition when it involves too much risk. There's too much risk in taking this and bending this up, and next thing you know, I've introduced another problem. Don't even realize what the problem is I've introduced. So going over it again, we have a coil. From one lead to the coil, it reads 17 ohms to ground. There's no sign of a ground connection. The other lead leaving the coil appears to be open circuited. Cannot find a ground looking back or any resistance. There's a ground available right down here. Like really, I was going to say, so maybe this wire, but if this was connected there, then you'd see a ground here all the time. And we don't, do we? We don't, do we? Do we? We do not, do we? Good. If a ground showed up there, that would have been the end of the video for today. So what it really looks like is somehow there's a short to ground in that coil, a solid short. Like it's not wonky. It doesn't go up and down or come and go. It's not intermittent, to use proper words. Removing this single coil itself. Well, what is holding it in there? So it's being held in here. Wow. If it's being held in at the other end, which it is because it's solid, then this has to be soldered to something at the other end of this coil. So I want this trimmer capacitor to be connected across the coil. So, or to ground, and I think it's to ground, right? It's to ground where it's going. Yes, thank you. That would have been the end of the video. So it's going to ground. This has to be the problem. This has to have been. Yeah, maybe you tried to solder this wire on and missed, but ended up soldering this. Yeah, maybe. So can I hit the other end of this green wire? Do I know it's even connected right to that terminal, let's say? So it's not connected to the potential ground terminal. What is it connected to? Is it connected? Not connected through the coil. The green wire is not connected. It's connected to nothing. The green wire didn't make it where it's supposed to go, and instead the grounded capacitor got connected. We got to get a look way in there. We got to get a look way in at the back of this thing. I have to figure out how I can do that. How can I do that? Now, that could involve swinging the stuff out. Okay, I'm going to ponder that for a minute here. Okay, here's what crazy ideas come to mind. This is my box of junk telescope parts. In here will be a 45-degree reflector somewhere down in this box. Oh my gosh. I see it all the time. You know, does that happen to you? I see it all the time, but I don't know where it is. Well, I don't see one right here, but I do have another sort of one here. Okay, so that's out of the center of a reflecting telescope. Oh, it's really wrecked. Yeah. So I want to use this as a reflector, shoot the camera in here, and look back that way. Shoot the camera this way, look over there. That's my theory. I'm getting these things off. Didn't even need them. Oh boy, this mirror's not quite. I need to take all this stuff off. Now this is one telescope I won't be looking through again. So I have a reflecting telescope, you know, the kind with a mirror in them, and the cheap telescope. That's the wrong screw. To get this off, I got to do this screw. Since I had this new all-in-one telescope, and probably never use my other telescope again. Probably. Come on. There we go. Yeah, it's actually scratched on. Maybe, you know, that could even be. There's various things that can happen to these mirrors. So I'm going to try to put that like that. And look into the mirror like this. Yeah. So there's going to be focus issues here, for sure. I've got this focused up way too close. Let's see if we can set this in place. Okay, I think I'm looking at this, yes. That's not far enough back. We need to look way back here. Okay, I'm going to adjust the focus because we're starting to be able to see. Just bear with me a moment. Okay, what do you see? What do you see? So the first thing we see is the closest coil. I am awake, and we're not focused anywhere near the more rear coil. Wait a minute, look at that copper wire right there. Yeah, it's probably, what is that? That's not soldered, is it? That's not of particular interest, but there it is. That's another. We really want to look further back. Okay, I'm going like that. Don't get sidetracked here. What's our focus distance? Oh, it's way back here. Okay, we're getting there. Well, it's so far away in the camera. How am I going to figure out what I'm seeing there? We need to go, so I think what I see is, briefly, is an almost empty terminal. That's not far enough. We need to see farther. We also need to see upwards a little bit. Oh my gosh, that's not going to work. I don't know if that's going to work. I can't possibly get my camera in there. I'll have to get my my ear camera out. I need to do that. Before doing that, Oh, I've got the focus way out here. That's way off. That's way off. Can't be that far. Oh my gosh, look at it. Should be set somewhere around here. Okay, so we're looking right where I want to look. Pretty well. Where's my? I dropped my stick. Oh my gosh. Okay, so we're looking. We're looking where? We're looking here. We're looking right here. That's definitely it. Now, what are we looking for? We're looking for. See, now I got the stick between the coil and the terminal as much as we can see. Oh, it is definitely connected here, isn't it? So why we got a ground here, but the green wire, where's the green wire now? The green wire is supposed to come here. I'm trying to flex it. Oh, it's going by. Oh, it's coming over to this terminal here. That's where the green wire is going. Well, that explains why the green wire doesn't seem to do anything with this coil. It's nothing to do with the coil. So this is the ground point and must be the second terminal for this coil. So what's the problem? There's no problem. The problem is I'm just getting the puzzle parts together wrong and then coming up with weird pictures. Well, what's that mean? That means everything's fine with this coil. That means everything's fine with the coil. 17 ohms sounds about right. Going to ground, that's okay. So what? So okay. So if that's the case, then the problem must be the secondary. So we're going to look at that tomorrow. Tomorrow, okay. I think it makes sense to hunt for trouble on the secondary at this point. My gosh, oh boy, this is what happens. This is why when I'm working on these radios, I'm so anxious about all the coils and accidentally damaging them or doing something to them because they're so difficult to work with. And I did manage quite a few years ago to actually drill a hole through a chassis and put the drill right into one of these coils. Actually, not like this, but a different kind of coil. But nevertheless, I drilled it, and I guess what I had to do? I had to buy another radio to get the coil. Oh my gosh! So ever since then, I've been super gun shy on these things. Well, that's okay. We just keep hunting, and sooner or later, the mother lode is going to appear. Thanks a lot for watching today, and I'm off to have a day outside from here. See ya.